Welcome to our first online lesson for geometry, standard version. Today we're going to be learning about points, lines, and planes. So, points, lines, and planes are the basic geometric objects we're going to use in this class. They don't really need any specific definitions. As we use them more and more, you'll see examples. So, if the definitions don't make sense, it's because there's something that can't really be defined. There are sometimes what's known as undefined terms. So when we think of a point, we usually just think of a dot. We imagine it as being an infinitely small dot. So like if you click a mouse on a computer once. A line is what you get between 2 points. It's a one-dimensional object. So it has two directions, right and left, or up and down, or whichever direction it's going. And it can be represented with either a cursive letter like L, or with the names of points it goes through. So if it goes through points B and C, then we can call it line BC. So in the book, if you see a cursive letter like L, that's the name of a line. Or if you see something like this, two capital letters with an arrow, double arrowhead over it, that also means a line. Okay, what is a plane? A plane is a two-dimensional thing, so it's like a sheet of paper. So planes will either be listed as just a single capital letter or 3 points. Now, why do you need 3 points? Well, imagine trying to balance like a book on your finger. If you balance it on 1 point, it can kind of wobble back and forth. If you balance on 2 points, it can still fall over. But if you balance on 3, it won't fall over. To completely balance a book, you need 3 points. And to completely understand a plane, you need 3 points. So points, lines, and planes each have a dimension. Dimension just means how big are they. Points have a dimension of 0, the lines have a dimension of 1, and planes have a dimension of 2. Okay, this is exactly the kind of stuff that the Euclidean geometry class has been studying. So you guys are at the exact same point now. Both of you are studying what's known as postulates as well. Postulates are just rules that we decide that work in geometry. So unlike other areas of math where we try and find rules that already exist in nature, in geometry we make up our own rules and just see what are we allowed to do with that. So I'm just going to make up a rule. And the rule that I make up is through any 2 points, there is exactly one straight line. So from now on in this class, if you see 2 points like A and B, then we know that there is at least one and exactly one line going straight through them. So how do you use that? Well, we'll just say later on, draw the line from A to B and just assume that we can do that. Okay, can you guess how many points we need to make a plane? You can go ahead and pause it here if you need to. That's right, through any 3 points is exactly one plane. So if you mark any 3 points in space or on Earth or whatever, and you connect them all, there's exactly one book or sheet of paper that they go through. Okay, so if you'll turn to page 15 in your book, you can see they have a couple of examples there. I think it's pretty straightforward, and I don't want to redraw it here, so I'll have you look at example 1. Example 2 is slightly more complicated, so I'm going to do example 2 for you. Okay, so imagine that there is a plane out there, and that above that plane is a point H. And that below H, it goes into the plane, straight through it. The place where it hits the plane is point E. Point G is just random. And then another line is on the plane, and it goes through D, E, and F. If you don't like my picture, go to the same picture on page 15 for example 2. Okay, notice that some of these things have some things in common. For instance, D, E, and F are all in a line. So, we need to come up with a name for that. So, together on a line, and the Latin word for together is col. So, we're going to say collinear points are points that lie in a line. Coplanar points are points that lie in a plane. And coplanar lines are lines that lie in a plane. So for instance, in this picture here, they ask us to name 3 points that are collinear. H and E are collinear, but nothing else is collinear with them. They have to be all collinear together. D and G, any 2 points are collinear because we can draw a line through them. We need 3 points that are collinear, and so my line's a little wobbly, but D, E, and F are collinear. Again, feel free to pause when you need to. Now if we have to find 4 points that are coplanar, see, any 3 points are automatically coplanar. Because what does coplanar mean? It means that they lie in a plane. And any 3 points lie in a plane. How do we know that? Because that was one of our postulates. And the postulates are things that we say are true. So if we say it's true, you have to believe it. So we need to find 4 points that are coplanar. Well, there's only one plane at all. It's that big square. So I'm just going to list everything in that square. As for coplanar lines, there aren't really any here. But the book is asking for 3 points that are not collinear. So just pick any 3 besides D and F. So like H, G, and D are not collinear. So if you don't understand collinear or coplanar, it's okay. One way to think of collinear is collinear points are points that can be touched all at once by a straight stick. So D, E, and F, we could put a stick straight through them, that'd work. But no stick can go through H, D, and G. The stick would have to be bent like a triangle. Coplanar points are points that could be touched by the same plank of wood. So if you had a really big plank of wood, we could lie it on top of D, E, F, and G, and it'd lie flat. But if we tried to do like D, H, and F, and G, so like D, F, G, and H, we couldn't have the same plank touch all 4 of those points at once. You could put it on 3 of them, but 1 would be left out. So coplanar means you can touch them with a plank of wood. Collinear means you could put a stick on them. Okay. Doing the checkpoint at the bottom of that page will also be useful. Okay. Now, there's a difference in lines that go on forever and lines that don't go on forever. So, the line that goes on forever is called AB with an arrow over it. That's the whole line. AB with just a line over it is called a line segment. So that's just a shorter bit. So the AB with the bar, I'm going to draw this in red. So just so you know which one I'm talking about. This is the line segment AB. It starts at A and ends at B. Let's use another color for array. Because we can also have array AB, and that's just half of an infinite line. So that one starts at A and goes on forever in the direction of B. So lines, line segments, and array. Okay. These two are symmetric. Like if you switch A and B, it doesn't matter. It's just a line. But if you switch A and B in array, it matters a lot. Because AB in that direction means you start at A and you go here forever. But BA in the other direction would look like this. So they're very different. Okay, so I recommend you try example 3. Please, if you have any questions, go ahead and ask me. Otherwise, thank you for listening today.